Okay, so to divide fractions, you do not divide the tops and divide the bottoms. It is not the same rule as multiplying. So do not do this. Do not say, oh, 9 divided by 3 and 10 divided by 5. That is incorrect, not true. Instead, we have a rule. We turn division into multiplication. And the way we do that is with this rule right here. Dividing a fraction is the same as multiplying by its reciprocal. What is a reciprocal? You might not remember. That means flipping the numerator and the denominator with each other. So division is the same as multiplication by the reciprocal, is the words. Here's the rule in action. We do two things. We change the division sign to a multiplication sign. There's step one. In red, we change the divide to a multiply. Notice we didn't touch the 9/10. The first fraction stays the same. We change the division to a multiplication, and then we flip the second number. So instead of 3/5, we make it 5/3. What a weird rule, you might be thinking. I will talk a little bit after a couple examples of why, just a little hint of why that works. But the main thing is you just want to remember that rule. Change the division to a multiplication and flip the second fraction. And that is how you do division. So here we've taken our first step. We've changed it to multiplication by the reciprocal. And now it's just multiplying. So now we just follow our multiplying rule. 9 times 5 on the top is 45. 10 times 3 on the bottom is 30. Or I could have reduced 9 and 3, reduce, both divide by 3. Or 10 and 5, reduce, both divide by 5. But I chose this time to just, the numbers aren't too big. I'm just going to go ahead. 9 times 5, 10 times 3, 45 over 30. And then I noticed that 15 goes into both of those. Or if I didn't notice that, maybe I noticed that 5 goes into it, and then I do a further step of reducing. I eventually get to the same place. 45 divided by 15 is 3, and 30 divided by 15 is 2. So there's our answer. Or if the question says it wants a mixed number, that is 1.5. 2 goes into 3 once, with 1 left over. So there's the dividing rule. Change the division to multiplication, flip the second fraction, and now you just multiply. Right, so why this weird rule for dividing fractions? So I say here that if we can see that it works in one simple situation, then at least it might help understand a bit. To really prove this to you, we gotta wait till you know a little bit more math, more like Math 053. Then I could show you a proof, and a formal official proof of why it works. But for now, it just helps us to think about it. So let's say that you have $100 and you want to give that $100 to your math instructor. Oh, no, that's not what it says. $100, and I want to multiply your money by half. How much money do you have now? I think most of us could come up with the fact that we have $50, right? You have $100. I'm going to multiply your money by half. I'm going to cut it in half. You have $50. So in other words, 100 times a half is 50. Now let's ask the same question a different way. You have $100, and I say I want to divide your money by 2. How much money do you have? Again, $50. $100 divided by 2 is 50. So 100 divided by 2 is 50. So here we have two things that we can do that both turn 100 into 50. We can multiply by a half or divide by 2. Now, what we want to remember here is that 2, remember, as a fraction, is actually 2 over 1. So let's change it. So here's the two things that are the same. Multiplying by 1 over 2 is the same as dividing by 2 over 1. And that's just sort of from a practical thinking about me taking half of your money away from you kind of example that shows us that those two things are the same. So division by 2 over 1 is the same as multiplication by 1 over 2. And that same pattern carries on to every fraction. And again, the formal proof of that is something kind of beyond where we're at right now. So you kind of have to trust oh yeah, okay, I see that sort of makes sense. And one day in future math, you can get proven exactly why that always works. So let's try a few now. We know the rule. Do not be tempted to cancel. Remember that canceling tops and bottoms is only for multiplication. This is division. Do not cancel the 5 and the 10, right? So the canceling rule we came up with only works for multiplication. Instead, we are going to follow our 2 steps. Switch the divide to a times. In red, there's step 1. I switch the division sign to a multiplication sign. Step 2, flip the second fraction. So 10 over 21 becomes 21 over 10. And now that it's multiplication, now you could look for some canceling. You could just multiply. 4 times 21 is 84. 5 times 10 is 50. You could do that. Here, let's write that in. You could take that as your next step. That canceling is getting just a little bit, they're both even. What else? What's going to cancel out? I would suggest that on this one, it's probably worth looking for the reducing first. So especially since you have a very obvious one there, 4 and 10 are both even, so they can both be divided by 2. So I do it. 4 divided by 2 is 2, 10 divided by 2 is 5. Reduce that fraction. I don't think anything else reduces. There's 2 5s, but they're both on the bottom, so we can't cancel them. 221. Yeah, I think nothing else cancels. So let's see what's left. 2 times 21 on the top, 5 times 5 on the bottom. I think that was easier than reducing 84. Well, maybe not. Either way, in this case, could have gone either way on that one. The key is that when it's a division sign, we cannot cancel tops and bottoms. When it's a multiplication sign, we can cancel tops and bottoms. Over here on this next one, I think we got to turn that 5 1/3 into a mixed fraction or an improper fraction. 5 times 3 is 15 plus 1 is 16. So now we have 2 fractions ready to divide. So we follow our 2 steps. In red, change my division sign to a multiplication sign. In blue, flip the second fraction. 4 over 9 becomes 9 over 4. I'm thinking 16 times 9 is definitely big enough that I don't want to do that multiplication. So let's see if we can reduce anything. I see a 16 and a 4 on the top and the bottom, both divisible by 4. So let's do it. Cross them both out. Divide them both by 4. The 16 becomes a 4. The 4 becomes a 1. I also spot a 3 and a 9, top and bottom. They both divide by 3, so cross them out and divide them both by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. I don't see anything else that cancels, so what's left behind here on the top? 4 times 3, 12. On the bottom, 1 times 1. 12 over 1. We would never write 12 over 1 because 12 over 1 is simply 12. So when you end up with an answer that has a 1 on the bottom, just write it as a whole number. And on to the last one here. 12 over 5 is good, ready to go, but that 10 will not. We cannot work with it as a 10. We have to turn it into a fraction, 10 over 1. I'm going to say it one more time. This is a division sign, so do not try to cancel tops and bottoms. Instead, we turn it into multiplication. Yeah, do not cancel the 10 and the 5 because it's not multiplication. We turn the division sign to a multiplication sign. My computer's going very slow. I don't know if you notice. I click to the next slide and wait for like 4 seconds. And we flip the second fraction. Now I can look for canceling if I want to. I see a 10 and a 12 are both even. There, 10 and 12, both even. They both divide by 2. Cross them out. 10 divided by 2 is 5. 12 divided by 2 is 6. And that makes getting to your final answer so much easier, because instead of having to reduce big numbers, you just go 5 times 5 is 25, 1 times 6 is 6. There's the answer if they want an improper fraction. Or if they want a mixed number, 6 goes into 25 4 times with 1 left over. 6 times 4 is 24. So there's some dividing fractions examples. And I think I probably have a couple for you to try next. Yeah, so let's take 5 minutes maximum. Okay. There they are worked out. So turn division to multiplication and flip the second fraction. So it became times 5 over 3. Simple multiplication on the top, 8 times 5 is 40. And when I say simple, remember, I'm assuming you got your times table sheet in front of you, so even if you don't have them memorized, you can look along the sheet, right? 8 times 5 is 40, 11 times 3 is 33. As a mixed number, 33 goes into 40 once, with 7 left over. And over here, got to make sure that they're both single fractions, not mixed numbers. Change division to multiplication. Oh, you notice over here, nothing canceled, right? If nothing cancels, nothing cancels. That's just the way it is. Over here, we do have some canceling. The 25 and the 15 can both be divided by 5. So we end up with 5 times 1 on the top, 8 times 3 on the bottom. 5 24ths, nothing to do with that. It's not an improper fraction, so we just leave it as it is. Okay, so this is more for the 05 level students for sure, because they're gonna teach you your fraction stuff, and then they're suddenly gonna start tossing letters in instead of numbers. And we talked about a little before about how this is where your calculator becomes useless. So 3 over 5 times t over 7, well, it's exactly the same rule. Multiplication, you multiply the tops, multiply the bottoms. So on the top, we have 3 times t. How do we write 3 times t? Well, we have a whole bunch of options. We could write, I'm just going to go in here and write a few of them down. You could write 3, oh, it is going so slow, times t, like so, if you wanted. Or you could write 3 dot t would be true. You could write, this is for the top of the fraction only, in brackets, 3 bracket, t bracket. You could write a 3 in front of the bracket, 3 times t. That's also correct. Or you can even just, with a number and a variable, you're even just allowed to write 3t, like that. Well, that is by far the easiest one of all those options, right? Just 3t instead of any of these other options over here. So that's what we're going to do. We are lazy. Mathematicians are incredibly lazy, you will discover, in how they try to take shortcuts to save time. So we're going to take the simplest option. On the top of the fraction, we're going to write 3t. And on the bottom, we're going to put 5 times 7, which is 35. That's all there is to it. It's the same rule as the other multiplication. Now there's a letter there. Oh well, who cares? Don't let it bother you. 2 over p divided by 5/8. Well, when we're dividing, we have to turn it into multiplication by the reciprocal. So 2 over p times 8 over 5. On the top, 2 times 8 is 16. On the bottom, p times 5. Again, the easiest, laziest way to write that is just 5p, like so. So 16 on the top, 5p on the bottom, and you are done. There's nothing else you can do with that because you don't know what p is yet, right? Over here, you don't know what t is, so you can't work out the top. They might tell you at some point. They might tell you in the question later on, oh, hey, guess what? P is 12. Then you can plug a number in and work out that bottom. But as long as you don't know what p is, there's nothing else you can do with this. Here we have 2 over 15y times 9x over 10. It's just fraction multiplication. Multiply the tops, multiply the bottoms. We can do 2 times 9. That's 18. and then there's an X sitting there. Well, we can't do anything about that. Oh, never mind. Oh, back up. We're going to do some canceling first. Sorry. I noticed that on the top and the bottom, 2 and 10 are both even. So I cross them out, divide them both by 2. You don't have to do this in the first step, but if you don't, you have to catch in the final last step that you can do some reducing. I just got a ding from an email. I'm just going to check. Nope, nothing to do with class. Good. So, and then I also noticed the 9 and the 15 are both divisible by 3. So I do it. I cross them both out. I divide them both by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. Now I've made things simpler. Multiply the tops. 1 times 3 times x. Well, that's just 3x. And on the bottom, 5 times y times 5. Oops, that's a mistake. 25. 5 times 5 is 25 on the bottom. And a y. And look, the x and the y, everyone kind of starts to freak out when they start to see the letters. What I want you to really start to notice as you're heading into these O5 level courses, especially for those that are, is they really don't, they don't do anything, right? The x is there, the y is there. Don't let them stress you out. So there's an x and a y in your answer. Doesn't bother us, right? Over here, 5 times 2m and m times, 5 over n times 2m over 3. Watch what I'm going to do. Here I cancel the 2 and the 10 because they could both be divided by 2. I canceled with the 9 and the 15 because they could both be divided by 3. Well, here, look what I have. I have an m and an m. An m and an m on the top and the bottom, which I'm pretty sure I want to put in red. Yeah, there we go. I can divide the top and the bottom by m. I can cancel those out, swipe them out, divide m divided by m is 1. So it just cancels out to a 1. So if you have a letter on the top and the bottom, the same letter on the top and the bottom, they will actually cancel out. Now I just multiply 5 times 2 on the top, 1 times 3 on the bottom. That's 5/3, or this particular one, you could make 1 2/3. I want you to notice one thing. This run right here, the second one that we did, notice I didn't try to turn that into a mixed number, and that's because of the variable. If you have a variable in it, you can't. There's no good way to write it as a mixed number. You can't say 3 and 1 over 5p. It's not true. So if you have letters in your answer, do not ever go to mixed numbers. If you have letters in your answer, just leave it as it is, because you don't know what that is, right? That p might be 1, in which case you have 16 over 5 times 1, 16 over 5. Yeah, that's a mixed number. But p might be 20, in which case you have 16 over 5 times 20, 16 over 100. You can't write that as a mixed number. So if there's variables, you do not switch them to mixed numbers. But here, all the variables canceled out. So I can write that as a mixed number. Okay, very last little thing here. This is, again, more for the O5 students. You're going to see this. One of the sections in your book is called Simplifying Expressions with a Fraction Bar. Fraction bar is just the line in a fraction. That's all that means. So you're going to get stuff like this, where we have it's a complex fraction. We have a fraction, something over something, but we have more stuff to work out inside that fraction. So what you're going to have to do when this happens is you're going to have to work out the top and work out the bottom separately. So let's look at that top, 6 plus 5 times 2. BEDMAS, we're back to order of operations. I should have written that up here somewhere. BEDMAS. So any brackets to work out? No, don't be tempted into thinking this is a bracket. This is actually just a 2 inside the bracket. There's nothing to work out, right? The bracket here is representing multiplication, because mathematicians are lazy, so lazy that they use brackets for 10 different things and confuse the heck out of students. So Nothing inside any brackets to work out. No exponents, no division, multiplication. Yes, we have 5 times 2, so that has to be done before the 6. So 5 times 2 is 10. Now we add 6 plus 10 is 16, and so the top of the fraction becomes 16. Now let's work out the bottom. 7 squared minus 1. Any exponents? Yes. I'm going to write it in again. Sorry, any brackets? No. Exponents? Yes. 7 squared. So we do that first. 7 squared is 49. Now we do the subtraction. 49 minus 1 is 8. And the bottom of the fraction becomes 48. So we took the top aside and worked it out. We took the bottom aside and worked out. Now we're going to reduce that fraction. The ideal would be if you happen to notice that the top and bottom can both be divided by 16. Let's pretend we didn't notice that. And I just noticed that they're even. Let's say we go that way, both divided by 2. So we get 8 over 24. Now we could divide by 2 again and divide by 2 again and divide by 2 again. Or let's say now you got y's and you said, oh, wait a minute, 24 is in the 8 times table. So these can both be divided by 8. Let's be smart and save ourselves some steps. Divide the top and bottom by 8 and we get 1 over 3.